Assalamu alaikum listeners. Welcome back to the recordings of Accounting Information System. Today I'm going to discuss a topic which is named as data modeling, and it will give you an insight about the basis of database, that what are the things we should take care when we are designing the databases. Do remember, we are taking this course as an accounting major students, so for us the understanding of the topic is important, so that when the developers who develop the softwares in the practical life, they are developing it, and if we are working in coordination with them, we know the basis, the terminologies which they are using. The ultimate goal of developing the database is not the concern of accountants, but yes, you should have an insight into it. You should have a basic knowledge and some details relevant to the databases. If you don't have them, then it will be difficult for you to understand that how they are developing it. We have to guide them. We have to make sure that all our required things are incorporated in the databases. So that's why the knowledge of the database development is important for the accountants as well. Let's move on towards the key topics which we are going to discuss in this chapter. It includes firstly about the introduction, then we will we will look into the overview of the database, and then we will talk about different steps which are involved in developing a database, and we will also discuss REA model in detail, its introduction we already took in the previous chapters. Finally, we will end our discussion with the discussion of normalization. So starting with the first introduction about the database, it's important to know that in current era, accounting information systems are helping accounting world, and these systems, they systematically records the data. That data is convenient and it is in useful formats for the users, and it helps easily accessing the data. Now, how does accounting information systems stores the data that is helpful for the users? So it stores the data into databases. So that's why the knowledge of databases is important for us. What is a database? So database is basically the collection of organized data, and this data is accessed by multiple users, different users in the organization. They are accessing this database, and it is used by many different computer applications. So if you store the data, let's suppose about accounts receivable into the system, it is used by many users in different departments. One person will be using it in the sales and distribution area. The other person will be using it in the finance department, who is dealing with the collections of receivables. Okay, and another department could be dealing it with the performance measurement of the sales personnel, that did they perform according to the targets or not. So one factor is used in multiple location, in multiple computer applications. You know that in SAP or other ERPs we have multiple applications, so that's why we are using that multiple applications uses this data. So how the data is being used in the databases? So basically, database management system, DBMS, it is a software which manipulates the data and create the required informations for the users. Why the databases are important, why they are significant? So they are significant because of the following reasons. Starting with the critical information. In an organization, the databases, they stores valuable information, very important information for the organization. So that's why they are significant for the organization, because millions and billions dollars of businesses are stored in the databases. Volume includes the number of transactions, number of records a database maintains. So the huge amount of data is being stored in the databases. Take the example of YouTube. People watch millions of videos on daily basis on YouTube, which are stored on its database. So you can see it helps in saving volume, huge volume of data. Then comes the distribution. Databases in some organizations, they are centrally stored. Centrally means in a main location, and different departments, different users, they access this information. But sometimes their local copies are also saved on regional or the department level. So the original data which is stored on the central location, its copies are being used in department level, or you can say in different regional levels for the processing purpose. But do remember, if its copies are being used, then in that case few problems could arise, like accuracy of the data, or you can say the completeness of the data, or the consistency of the data, and the security of the data on these other locations other than the centralized location. So the central data is being distributed in different places. Then comes the privacy. Privacy means the sensitive information which is saved on these databases, it should be secured, because it's private information which is relevant to the customers, which is relevant to the employees. So the protection of this private information is very important, because if organizational privacy is not being secured, then in that case their competitive advantages, or you can say their businesses, could have adverse effect of it. Then databases contains irreplaceable data. Now what does irreplaceable data means? Irreplaceable data means the data which is stored on these databases, it's of unique nature. If it is lost, it can create huge amount of losses for the organization. So that's why its importance, database is important. If it is important or significant for the organization, then organization will put more resources to make sure that the data is not lost. Need of accuracy. The data stored in the database, it should be complete, it should be comprehensive, and it should be accurate. If it is inaccurate, like I explained in one of the topics which we were discussing in the previous lectures, I said that if instead of putting 40,000 you enter 4,000, input is inaccurate, then whole processing will be based on 4,000, not on 40,000, which is actual entry. So accuracy is important in the databases. So when you enter the data into the databases, it should make sure that the data is accurate. Then finally, internet uses. Databases, most of the databases, they are used by internal as well as externals users of the organization. The most common example is website of a company. It includes the financial statements of the company. It includes you can say the career opportunities of the company. Then it includes products and its pricing on the website. So databases, they are important for the internal as well as external users as well. But when it is accessible by external user, again the security should be taken care of. So these are the points which can tell you that how the databases are important or significant for the organization. When we talk about databases, so we should remember that we store our important data on the databases. So data is stored and organized in the databases in a systematical way. So there are three very important concepts about which we should be clear when we are talking about storing the data on the databases. So these three important concepts are data hierarchy, record structure, and database keys. So let's have a look at them one by one, starting with data hierarchy. Okay, so data hierarchy means storing the data in a logical way, in a proper way. There should be a proper order. So data organization in ascending order is known as data hierarchy. What is order? Order means it starts from the smallest thing and it moves towards the big stuff. So firstly, we have a data field. This data field saves the data record, and then a set of records makes a data file, and many data files, if there are many, they make a database. So you can see it starts from a smaller scale and it goes to a bigger level, starting from the data field and it ends on database. Okay, so let's see. Do remember they are in order, so always the data field comes first. We have firstly a data field. Different data fields, they makes data record, different data records make data files, and then different data files makes database. So the order is ascending. When I say firstly, let's talk about what is data field, then I'll take you towards the data record. So the first level of data, this is hierarchy, right? This is data hierarchy. So the first level of data hierarchy is known as data field. It is having an information which can describe a person, a thing, or you can say it could have an event stored in it. So for example, if I talk about a payroll file of an employee in an organization, so data field would be employee name. The name, it's a box, and the name of the employee is a data field. Or you can say his national ID, it's a data field, right? So you can say each cell, it's a data field in which we store the data. There are some other names of the data fields as well, like we call it as an attribute, we also call it a column, or simply we call it as field. Okay, the second level in the data hierarchy is known as record. So record is, you can say it's a combination of fields. It's the second level. Data fields combines together to make a record. Can you see over here in the diagram? This is a data field, this is a data field, and when we combine the data fields, we get data record. So the social security number of an employee, his last name, his first name, which department he belongs, his pay rate, when did he join the organization, does he have an overtime, and any other information. So different data fields, when we combine together, they make record. Okay, and usually in accounting information systems, the record structure is usually fixed. The record is also known as tuple, T-U-P-L-E, and it stores the information about this record. Could be about a person, about an event, about a transaction, about an asset, right? So it could be about, you can say, person, event, or thing. So the common examples from accounting perspective could be the information about an inventory item, or you can say the information about you can say accounts receivable, or the information about a vendor. So all these things, they are the example of the records. Moving on towards third thing, that is, if you see over here, we have a file. So I did not put a proper picture for the file over here, but do remember, in a table we also call, you can say it's a table or a file. So I will have social security number not only for one employee, I will have for all the employees of the organization, and it will look like an Excel file, right? So that is a file. So a file has many records in it, just like a record has many fields in it. Fine. Moving on towards the third thing, that is the database key. So we use you can say different types of keys in the databases to link them with each other. So the two common keys which we use in the databases, they are known as primary key and the foreign key. When I say primary key is unique to each record. Like if you see this table which I just discussed few minutes back with you, the social security number, if this is an employee record file, the social security number will be different for each employee. It's just like your national ID, right? So it will not be repeated, because in a one organization one employee will have only one social security number. So this is the primary key. It's a unique key. It's not repeated in this database. Foreign key is a reference key, and it could be the reference key of one or more records. When we try to link different tables with each other, different files with each other, let's suppose this is one file and this is another file. This file contains the employee information, that how many employees the organization have. So I will be having the national ID for the employees. Okay, I will be having the department of the employee. Let's suppose he works in department A. I will be having the name of the employee, because this is the employee record field. Then there is another file which I am having, and that is regarding the department. Okay, so in the department I am having a employee, this employee whose name is, let's suppose you can say Mr. Ali. So in the department, this is department A. In department A file we will have name of employee, and his name is Ali. His ID, national ID, will be here, and his date of joining will be here. Now I want to link my first table with the second table. So what is the common field which is here in table 1 and the table 2 as well? I cannot say Mr. Ali, because the department could have more than one Ali, right? So I can say national ID is the one which I can join two tables together. It's a repetitive key, and in table B it could be a reference key for the table 1, and it will be helping me matching table A with table B. Right? So foreign key enables the referencing of one or more records. It matches the primary key of the related table. So if this is the this key is matched from table A and table B. So do remember, we have two types of database keys. Primary key is the unique key of each record, and then the foreign key matches one table with another table. Here you can say in table A I have department is the foreign key in table A. Primary key in table A is the national ID. National ID should be means the primary key should be unique, but foreign key could be of repetitive nature. Like I could have in employee table more than one employees from department A, so foreign key could be repeated. Same is the case in my table B. I could have primary key and the foreign keys, right? So it's while designing the database, we do this, we identify different keys as primary or the secondary key. So later on, when we are trying to extract the record about an employee, about an asset, these keys helps us in extracting that record from different tables, and our required table will be formulated. It's an example for you. I have two tables with me. So the first table is the employee table. It has social security number, last name, first name, department code, his pay rate, joining date. This is one you can say file which I have, data file which I have. Or the second one, another table or another data file which I have, that is about the department. So department A has manager this, and his employee numbers are 45, location is building this, and the secretary phone number and other information. This is about department. So this table or this you can say file will have detail about all the departments: department B, department C, department D. And because department will not be repeated again and again, so they made primary key as department in this department information table, but in the first table, which is employee record, they made social security number as the primary key. Okay. Now if for example you want to extract a third table, or you want a record, or you want a file which contains the names of the employees, and you also want to see from which department they belongs, who are their managers, what is their work location, and the contact person in that department. So these two tables will be used to extract this information. Can you see the first name and the last name of the employees will be extracted from this employee record file, and the department from here, and it will be matched from this department over here, right? So this one you can say it's a foreign key. And then after that we have manager information is also will be extracted from here. Then the location will be extracted from here. The contact number will be extracted from here. So when you have foreign key in one table which is matched with the other table primary key, then in that case database seems it easy to extract the information from different tables and create your required information. You don't need to redraft the data again. These primary keys and second foreign keys helps in combining different data into a report structure, which is helpful for the reader. There are some other considerations which should be taken care of when we are discussing about databases. So the first one is database administrator. We cannot leave the databases unattended. Anybody can enter any sort of data into the databases. No. So proper supervision is too much important, because database contains, as I said, it's significant for the organization. So the person or the position who supervise the design, the deployment, the installation of the databases, also he needs to maintain, he needs to make the security of the data, and he needs to make sure that whatever changes are happening, they are accurate. The person who is responsible for this, he is known as database administrator, and he has too much powers and duties in maintaining the data. Then if these people goes on the wrong way, they can create huge amount of problems or disasters for the organizations. So database administrator is a position which holds huge powers and duties, and they are the one who administer the data. When I say administer the data, they make sure about the designing, development, installation. Then they are also responsible for the maintenance and securing the data in the organizations. So while hiring such persons in the organization, their repute, their creditworthiness is very important. Another important thing about the databases is documentation. Documentation means the proper description of each and every content which is stored in the databases. Like let's suppose if there is a field in the database and that is numeric, it does not allow alphabet to be stored in it. So its description will be stored in the documentation of the database. So if somebody tries to write an alphabet or a special character, error will be generated. Why? Because its description is stored as numeric. Okay, so then it's actually, it tells us about the structure or which type of content should be stored, or what is the feature of this record or this field. So and sometimes we right click on a field, it tells us about the description, that what should be written in this field. So that description. So how all these things are coming? Because they are the documentations which are stored for these databases. We also have a concept of data dictionary from the documentation point of view, so data dictionary, it's a critical component of the database documentation. What does it do? It describes data field in each database record, that which type of, this description, this is written about a field in the database, and we all of them together are stored in data dictionary. There is another important thing which we should know from the documentation concept, that is known as metadata. So metadata is a huge amount of data dictionary stored together in the metadata. So data dictionary contains metadata or data about data, or have a variety of uses. Data dictionary. Data dictionary is a critical component of database documentation, and this dictionary contains or it describes the data field in each database record. Just like a normal dictionary helps us in understanding the meaning of different vocab items, same is the case in a database. We have different data files, and data files have records in them. So for each record, the data dictionary tells us that which type of information, or what does the meaning of this data field that will be mentioned in the data dictionary. Metadata is a term which is used with reference to the data dictionary. So data dictionary, they contains metadata. And what does it mean? It means data about data. Means it tells more description, more detail about the data. Why do we have metadata? Because it has different uses. It can help those people who are not the original designer of the accounting information system or for the database, but they are the one who are improving it, or who are further adding some stuff into it. So this metadata could help them in understanding the database nature or different field nature when they are correcting or developing additional items into the database. So this is how the data dictionary looks like on the back end. What is field name? Field name is social security number. What is this is about one field. Which one? The one which we just took before this one, about only this field. Okay, so this is a field name is social security number. What is the size of it? Only 9 characters could be entered. The type of data field, it's text. We saw the number, but did you see hyphens are also there? So numbers and hyphen together, they are treating it as a text, and the other details are also there. So just like this, data dictionaries explain each and every cell, which in normal language you can say cell, or usually we call it as field. It describes each and every field of the record. Okay, some other issues regarding the databases, it includes data integrity. So integrity means it's very important to maintain the data integrity, because it's commonly said that if you added a data wrong, or you added an information wrong into the system, it costs 10 times more to correct it than what you have originally entered correctly. So data integrity controls are very important, because if the data is wrongly entered, wrong decisions could be made, and they can create disasters for the organization. So there are different tests with tests which we perform in order to make sure that the correct data is stored in the proper location. These are designed by the database developers, and what could be the possible example, like let's suppose there is a code regarding the state. Okay, the data which should be stored, that is state information. Now it should be just 2 digits, either SCA, either SA. So they make sure that such information only should be stored in this cell. So either they create the drop downs, or you can say they restrict the cell so that no other type of information could be added in this cell. Okay, so these are different data integrity control, and they are added into the system when the databases are being developed during the design stage, not after that. Okay, processing accuracy and completeness is another important thing that should be made sure. And again, this is make sure during the testing stage, while when you design the database, after that database is being tested, that it does not have any loopholes or problems. So the accurate processing and the complete processing is very important. AIS needs transaction controls. Why do they need transaction controls? To make sure that the accurate transaction is being processed. I'll give you a common example for this. For example, the company has let's suppose there is an inventory account for the company, and this inventory account has company has sold, let's suppose, 100 units of inventory. Okay, so when you do the sales, the inventory should reduce with 100 units, and these 100 units should be transferred to the sales account, right? Now this processing will be done by the system. Now, for example, the database reduces the inventory, but it does not increase the sales. So the processing is not complete, and now sales are understated, but inventory is correct. And there is missing processing, which will affect not only the sales account, but also your remaining financial statement accounts as well. So that's why accuracy is important, as well as completeness of the transaction is also important. Next is concurrency. Concurrency means a thing or a data is used by two users at the same time. Now this is accounting data. If two people are using the same account, like let's suppose in the storeroom there are the rims available for printing, those printing papers. Now let's suppose there are 300 rims which are available in the storeroom. This is the original data. Now there are two departments, Department A and Department B. Department A is procurement, and Department E is, let's suppose, advertising department. Okay, both of them at the same time, let's suppose they have users, and one user from the Department A and the other user in the Department B, they both are approaching to this record. User A, which is procurement, or you can say purchase department, he is approaching to this record because he wants to add 100 more rims which are purchased. So altogether there will be 400 rims. But at the same time, advertising department is using the rims from here. So when he used 300, let's suppose he took out 50 units out of it. Now according to his calculation, there will be 250. So this rim record will be confused. So that's why there is an added feature into the databases which block the second user to access this information when the first user is using this information. Whoever is first, if advertising department user approach the information first, he should be using this information, and he will be taking out 50 rims for the department use, and the database will update the record in the inventory department with 250 later. Then secondly, procurement department can access this transaction, and he can add 100 more rims into this, and now 350 accurate record will be there. So this is known as concurrency. We should have concurrency control so that multiple users cannot access the data at the same time and creates the confusion. So one by one people will be using the same record so that the up-to-date information is there. Moving on towards backup and security. As I said before, that the databases contains unique information on daily basis. Many transactions are being happening, and if the data is lost, it can create billion and millions of dollars of losses to the organization. So that's why backups, auto backup facilities should be there. It means ability to recreate the data, just like we take the backup on our hard disk or USB or other drive. Same is the case. Companies databases are stored on the back end, so backup are being taken at the end of every day, so that number one, it saves the important data of the organization, and if something happened to the local systems, the backend files could help the departments. When we talk about the backup security, we cannot ignore it. So we should also maintain the security for these backup files. We should prevent the unauthorized access to this data. From the security and point of view, there is another concept which we should be very careful, or we should know about, that is known as view controls. View control means limit the access to the data. Don't allow all the people to access everything in the organization databases. Provide access to the people only to those records, only to those databases on which they are working. Like, let's suppose production department manager should not have access to the sales department or other information. If he needs something, he should have only the reports availability, or he should request the department to provide the information to him. Then let's talk about marketing department. Marketing department should not have access to the finance department information. They should only be able to see the records or the data or reports of their department related stuff. So the controls should be limited to the users. Only what they need to know, that should be provided to them. How do we design the databases? So we design the databases with the help of REA model. So REA, we discussed it in the previous lessons, that R means resources, resources means organizational assets, events includes all the activities which are related to the business transactions, and then we have agents. Agents are people associated with these business activities. They could be insiders, they could be outsiders. How do we develop the database with REA model? So we have 6 steps. Firstly, I will list all of them, and then we will see their details. Identify business and economic events. Number 1. Number 2, identify the entities. Number 3, identify the relationship among the entities. Number 4, create entity relationship diagram. We also call it as ERA diagram. Then fifth one is identify attributes of entities, and number 6 is convert ER diagram into the database table. Okay, so let's see them one by one. Number 1, identify events and entities. First 2 points, right? What are the events? There are 2 types of events which businesses have. We have business events and we have economic events. Business events, they do not affect the financial statements of the companies, but they can affect the important aspects of the organization. For example, if organization figure out that we have a project already, and due to the expensive due to the change in the prices of material, the project cost will exceed our budgeted one. It's a business information, it's a business event, it's for important in making the decision, but it's not going to affect the financial statement as at this moment, because we don't have any financial transaction happening. It's an information for the organization. Whereas economic events are those events which affect the financial statements immediately. For example, sales of inventory, purchase of inventory, payments of salaries to the employees. So all these things are economic events. So firstly, we identify all the business and the economic events regarding the organization. Then type of database entities, because we are going to use REA model. So REA is the entity. All of them are entities for the organization. We have entities, agents, and the resources. Okay, so entities means events, agents, and resources. All of them are considered as database entities. So what could be this is better to call it as event. Okay, and all of them are as entities. So database contain data about different objects which are of interest for the databases. We call them as entities, and we know that we have three entities. Firstly, events. Events are all the as I said, business or the economic events. Then we have agents. Agents are those who are associated with these events. So we could have internal or external agents. The example of the internal agents are employees of the organization. Examples of the externals are vendors and the customers of the organization. Then talk about resources. Resources are generated by the organization, and these resources are used to generate further resources for the organization. So like, let's suppose cash, then you can say accounts receivable, then building. All these are different resources for the organization. We have this diagram for the examples of REA resources. Can you see cash, equipment, inventory, different plant assets? Events are sales, purchases, receiving the goods, hire an employee. Agents could be customer, employee, managers, vendors, insiders, and externals. Can you see we wrote here internals and externals? Then we have to identify the relationship among these entities. So entities, which just we saw, REA are entities. So we have different types of relationships among these entities. We can create direct relationships. We can create indirect relationship. Let's suppose the relationship between a sale and the inventory, or you are selling, the I means inventory, because you are doing sale to a customer. So the relationship between the inventory and sale is direct relationship. Relationship between sale and customer, it's direct relationship. This inventory is sold to this customer, but because of this event, right? So inventory has a relationship with the customer, but this is indirect. So like this, we have direct and indirect relationship, and we have to define it into the system. Since I'm talking about relationships, so I need to talk about cardinalities as well. The type of or the nature of the relationship among the entities. Can you see this inventory is a resource for the organization, sale is an event, and customer is an agent, and all of them are entities. So we have to define the relation nature between these entities. So what could be the relation between these entities? So we usually have three categories of relation, or you can see notations. We have one-to-one relation, we have one-to-many, so we call it, we don't write 1 to m, we say 1 is to n, one-to-many relation, and we have many-to-many relation. I'll be showing you with the help of example these different relations between entities. Purpose is occurrence of one entity associated with the occurrence of one event or another entity. So why do we create the relation? That, for example, this is inventory and this is sale, so we have to define in the system that this inventory could be sold out. Either we don't have any sale for this entity, we have one sale, or we have many sale for this entity. So like this we have to define the relationship. But for each sale there should be an inventory item which is sold out, so we say at least one or many inventory items should be there, right? So this is how we define the relationship, but we are going to discuss it in more detail in coming topics. So if you see here, I have three relations diagram. They all are defining something to you. So let's see. If you have a sale event means entity, resource means entity, agent means entity. So if you have a sales event, of course it should be made to a customer. So sale should have at least one customer. Without having a customer there will be no sale, right? So I cannot say no sale could have no customer. No, sale should have minimum of one customer, and one customer could have many sales. He can, because he's a customer of the organization, he could have many sales. So I'll be defining one like this, no like 0, and many like this. Okay, this is greater than. So this is known as maximum cardinality example. I have minimum and maximum cardinality example as well, that at minimum what could happen and at maximum what could happen. Here I'm telling you maximum relationship in this one. Now let's see the relation minimum and maximum cardinality example. This is the minimum and maximum, so I'm writing here minimum and maximum example. So number one sale is made to minimum of one customer and maximum of one customer. I cannot have one sale invoice for two customers. No, one invoice is sent to one customer. Okay, so one sale will have minimum of one customer and also maximum of one customer. It could not have more than one customer. For the customer, he could have made no sale transaction with the company, minimum of no sale transaction with the customer. He is a customer of the company, but maybe this month he didn't have any sales with the company, so I could have minimum of 0 sales, but at maximum he can have many sales during the month with the company, right? So 0 or maximum. Let's move on towards another relation diagram, that is many to many, or you can say maximum and minimum, both another example. So see here, one inventory item could have no sale during the month, but it could have maximum of many sales during the month. Maybe many customers have purchased this inventory item. But if a sale is happening, at least it should sell one item, right? We cannot say it did not sell any item. Then why it is sale? It is sale. That's why minimum of one item it should sell, and maximum of the sale could have many items. So like this, we have to define these relations in the system. But don't worry, accountant has to just see or theoretically explain it. The developer is the one who will be developing these relations in the system. So we design entity relationship diagram to explain these relations between different entities. The purpose of this diagram is to define the relationships among the entities. It has a proper structure. I cannot use any shape I want. I need to use different rectangles to present different entities. 3 items could be entities. We are discussing REA model, so resource, event, and agent model. So all of them could be the entity, and we will reflect them with the help of rectangles, sorry. And then there will be a connecting line between them, and it will be showing the relationship on them. Okay, so this is these are the things we need for the structure. We need rectangles to show the entities, and we need connecting lines with the relations on them so that we can show how these things are connected to each other. If you see, this is an ER diagram. It is showing us different entities connecting with each other to show a full sales process. So this is a sales process diagram. So let's have a quick look over it. In the first instance, we have inventory, and then okay, so what I'm going to do, this is R. So all in this diagram here, I will be placing resources. Okay, this is event. So over here, I will be placing all the events, and these are agents. Over here, I will be placing all the agents. Okay, so let's place all those people who are involved in this transaction. Let me just clear the screen so that we can quickly see that. So I have firstly, in a sales transaction, 2 resources are involved. What are the resources? Our inventory is sold out, and ultimately at the end of the sales process we get cash, right? Who are the people involved in this? So we will have look at your organization. Okay, in your organization, who are the people who are doing this work? So there is a sales person in your organization who is selling the goods. Of course, you have a customer to whom you are selling the goods. You need to ship the goods, so shipping clerk is separate than the salesperson. And in accounts department, you have an accounts receivable clerk. So place all of them. Now find out the events with which they are connecting with each other. So firstly, we get a customer order. So event is customer order. These are agents. Okay, customer order event we get. Who places this customer order? So put a line, this one. Customer places this customer order. And who in the organization, who is processing this customer order? This salesperson is processing this customer order. So basically, customer order is the event which is created and processed with the help of 2 agents. One is internal, that is salesperson. The other one is external, that's a customer. And this customer order is going to use a resource, that is inventory. Now after this, second, we need to ship the good. Who will be shipping the good? This agent, shipping clerk, will be shipping the good. To whom? To the customer. So he is shipping the goods, and shipping goods are going to the customer, and these shipping goods are what? They are coming from the inventory. So resource is being used. And then by doing this sale, we will be getting the money. So who will be collecting the money? Account receivable clerk will be processing this receipt of payment. From whom? From this customer, and we will get cash. So we defined our whole process of sale in this. Now let's create the relations. Okay, so starting with first, because we draw the lines, now we need to show the relation 1 to 1, 1 to many. So an inventory item could have no sale, or it could not have any customer orders. Minimum 0, and maximum it could have many customer orders. So I created this because of the line, it is having this sign. Okay, a customer order should have at least 1 inventory item, and it could have many inventory items as well at maximum, right? Moving on towards the relation between customer order and salesperson. One salesperson could have no customer order at minimum, and at maximum he could have many customer orders. A customer order should have at least 1 salesperson, and also at maximum only 1 salesperson. 2 salesperson cannot process 1 customer order. There will be a fight. Okay, so at minimum 1 customer order, and also at maximum 1 customer order. Moving on towards the relation between customer order and customer. So a customer order should have at least 1 customer, and also at maximum 1 customer, whereas a customer could have placed maybe no order, minimum, and at maximum he could place many customer order. Then relation between inventory and the shipped goods. An inventory might not have any customer order, that's why no shipping is being made at minimum, but at maximum we might have shipped it many times. A shipping goods should have minimum at least one inventory item, but at maximum it could have many inventory items. Then customer order and shipped goods. A customer order maybe does not need any shipment of the goods, but at maximum many times it could have shipped the goods. Whereas a shipping goods, of course, it could have, you don't ship the goods if you don't have a customer order, so at least you should have one customer order, and at maximum you could have many customer orders. Then shipping goods and customer. So the goods, when you are shipping them, you will be shipping them to one customer at minimum, and of course to one customer at maximum. One set of goods cannot be shipped to many people, one customer. Okay, a customer could, maybe he placed no shipping order, so he will not have shipped goods at minimum, but at maximum he could have many shipping goods because he placed many orders. Shipping clerk could have shipped no goods because there was no order, or he could have shipped many goods. A shipping good event should be handled by one shipping clerk at minimum, and maximum also one shipping clerk. Then moving on towards the payment receipts, or receipt of the payments is a bit, and shipping goods. So maybe shipping goods does not receive any payment because it's still pending, or maybe it have many payments of receipt payments because they are cash transaction. As soon as goods landed, we get the money. Receive payments should have at least one shipping goods, because if you don't ship the goods, why you are receiving the payments? And it could have many as well. Account receivable clerk could have collected one payment, or it have collected many payments at maximum. Receive payment should have at least one clerk to be handling it, and also maximum one clerk should handle one receipt payment. Two people are not going to receive one payment. And then the cash, receive payment and cash also have very clear relation. Receive payment should, when you receive the payments, of course one transaction is bringing the cash, and also one transaction brings maximum one cash. Then maybe you did not receive any payment yet because it's pending, or maybe maximum you receive many payments. Customer, might be customer has not paid any money, or it has paid money many times. Receive payment, if you are receiving the payment, it should have at least one customer, and also at maximum one customer. So like this we define the relationship, and this is not possible for IT person to define, or define it alone. He needs an account knowledge background person who will be helping him. That's why you need to also understand this diagram. Then this diagram is transferred into the relationship tables, or we convert the diagram into the database tables. It provides greater flexibility, and we need it because we need to link different tables so that we can generate as much information we want. And these tables are linked with the help of foreign keys, and many relationship we define. Just now I showed you the cardinalities, the relationship between different entities, so they are defined to generate the database tables of your requirement. Like if you see this example which I just explained to you, this example has 9 entities. Can you see? Inventory is 1, customer order is 2, 3, then 4, 5, 6, 7, receive payment is 8, and cash is 9. So 9 tables will be on the back end. Okay, then we need 3 tables more to show the direct relationship, many to many relationship. First is inventory and the customer relationship, customer order, sorry, this one. Then inventory and the sales, and then sales and the receipt of the payment. Okay, so 3 more tables. So altogether we need 12 tables to generate the many-to-many relationship, and we can have multiple working in the database if we generate such relationships. So this understanding is very important, not only from the IT personnel's perspective but also for the accountants, so that they can help in creating a proper database which is required by the organization. Let's move on towards our next topic, which is normalization. Normalization is another important concept from a database perspective. So it is a method. In this method, you ensure that the attributes, they are stored in the most appropriate tables, and the design of the database promote accurate and non-redundant, redundancy means repetition. So it's a methodology in which you ensure that the data, all the data is stored in proper table, in appropriate table, and the data is accurate, and it's not repetitive nature in the data storage, because if you repeat the data again and again in different tables, the storage will be overlapping with too much information. So normalization process helps us in avoiding the redundancy, avoiding the repetition. We will be discussing the first 3 levels of normalization. There could be many more, but I will be introducing the first 3 from the accounting perspective. So first for a normal form, second normal form, and third normal form will be using. This is an unnormalized data picture, if you can see. We have social security. This is an example about you can say a student database about their parking and all those things, which cars they are using and all those stuff. So this is the social security number of the student, whose name and first name and last name. This is his phone number, which state, okay, this is the information about the car, so which state the car was issued, and what is the license plate number, and which ticket number he got. Ticket number means the fine, on which date he got the ticket, and why he got the ticket, so codes are there, and what was the fine against this code, right? So this is a non-normalized form. Why? Because this student got 3 times ticket during the month, and the repetition and empty spaces and these things are happening, right? Then the second student, and like that might be there are students who does not have any tickets, so then for them this area will be empty. So this is messy data, unnormalized data. We need to refine it. So when you refine it, you start refining it, that is known as first normal form of the data. In the first normal form, all the data fields are singular, and each attribute has only one value. We don't have plural information. They are repeated once, and each attribute has one value. Let me show you first, and then I'll bring you towards the problems of first normal form. So can you see here, we created a database in which we made the ticket number as our unique key. Can you see here the initial information? Social security number was the unique key, right? But now we made ticket number as the unique key, because it will be repeated only once, and it will not have any empty rows in front of it, empty, you can say, records in front of it. So see here, ticket number is 10151. It has a student social security number, his name, his phone number, his state, and all the details. So nothing is empty in this database. But yes, there is a problem. There is not one problem, there are 3 problems associated with the first normal form of this database. So what are they? Number 1, data redundancy is there. Can you see how many times this curry information is being used? Can you see that? Right? And then Mason information, his phone number is coming again, his plate number is coming. So there is redundancy, of course, a lot of redundancy is there. Second, we have insertion anomaly. What is insertion anomaly? Insertion anomaly means that you will be restricted to enter the data which you want to enter into the database. Like in our first table, there was no insertion anomaly. We can create as many student information who has a car, and if they have ticket, we can write their information as well. But if I create this database in the first normal form, I will have the information of only those students who have ticket. Those students who are following the rule and they still have car, we will not have their information in the parking area, right? So I am being restricted to insert those information which does not have ticket number, or those student records who does not have tickets, right? But I need to know because they are using the parking lot. So this is known as insertion anomaly. We have also deletion anomaly. Deletion anomaly means that if, for example, this Manson has paid all his tickets, so his information will be removed from this database, right? And then his record is gone. We don't have any backend record for this student or his car number or his plate number, so it's a problem. So we have deletion anomaly as well. So three problems are there with the first normal form. Data redundancy is there, insertion anomaly is there, which restricts you to enter the data which is not relevant to all the fields, and then deletion anomaly is also there, that if we delete, our record is completely deleted. Okay. So in order to avoid these three problems, we move towards the second normal form. So in order to move towards the second normal form, you should ensure that you have first normal form. It means I cannot create second normal form on this unnormalized data. I should firstly convert it into the first normal form, and then I can do the second normal form. Okay. And all the data items in this case depends on the primary key record. I explained you already the concept of the primary and the secondary key. Primary key is the unique key in the table which is not repeated again. So the primary key should be the foreign key in the other table, so that we can match the information and generate our required report. So all the data items, they depends on the primary key. So two features are there. Firstly, it should be in its first normal form, and all the data items, they depends on the primary record key. What are the benefits of second normal form? It's more efficient design, and it eliminates data redundancy. Repetition is gone. So how can we do that? So we will be breaking this table into two subtables so that the redundancy issue is not there. Can you see here from the first table, now I generated two tables instead of having one table. I have car registration table or file, and I have ticket file separate. Okay, in the car registration file, I have social security number, last name, first name, phone number, and the date when the state where the car license is issued, and the license number as well. Now we define this record requirements for this car registration file. Now let's identify which should be our primary key. Social security number, I cannot make it primary key because it does not fulfill the requirements of primary key. Primary key requirements are, it should be unique. It should not be repeated in the table. This is car registration table or file. So this file has all those students' records who have a registered card against their name. What if a student have two registered card on his name? So then in that case, his social security number will be coming twice. It will be repeating. So I cannot make it primary key, right? Because there is repetition. So what should I do? I will be using the license plate number, this number, as a unique key, as a primary key, because one license number, one plate number will not be issued to another car. So in this file, primary key will be the license plate number. Let's go towards the ticket file. So in ticket file, I have all the ticket now issued to the students against which number plates they are being issued, and then what is the date it was issued, what is the code, and how much was the fine against that code. Now students, if you see here, ticket number, I cannot give same ticket to two students or to two cars, right? One ticket will be issued to only one car. So I can easily make this it as a primary key. In this table, I cannot make plate number or car number as a primary key, because might be one car has two tickets, right? So then car number will be repeated. Like, can you see this CA It is repeated 3 times, so it's not a unique key. Unique key is ticket number. Fine. So primary, I will now be because they said unique key you should use. So in first table my primary key is the plate number, in the second table my primary key is ticket number. Now I should link them. How I'm going to link them? With the introduction of foreign key. So if I want to generate a report which has the record of the student who has ticket, and I need his whole record in my report, then in that case I need to link these two tables. So the primary key of the first table, I need to make it foreign key in the second table or second file. Fine. So foreign, when it will be foreign key, then a relation will be made between these two files, and it will be easy for the database that if they want to see, for example, to whom we issued this ticket, so they will get the license plate number. Okay, whose license plate number is this? This belongs to Curry, so his record will be also there. Fine. So we break the main file into small files so that the redundancy problem could be avoided, and when we generate a report, all these tables will be used by the database, and then they will generate our required report. But still we have a problem with this second form of normalization. Can you see over here in the ticket file table, the code is given that what you did. Like let's suppose here we have you get a ticket because you park your car in a wrong place. You get a ticket because you did not turn off the car when you was outside the car. You get a ticket because you cross the signal. So every code has a reason behind it, right? So A could be a reason, B could be a reason, C could be a reason. A person who get code A, he of course pays $10 fine. A person who got code B ticket, he gets $20 fine. C gets $50 fine. So I have the code and also its explanation in the same table. It's not acceptable, right? Because it's again something I'm explaining the same thing in the same table. So this is known as transitive dependencies. So we should avoid this transitive dependencies. So how can we avoid these transitive dependencies? We can avoid these transitive dependencies with the introduction of third normal form. In the third normal form, we can go for the third normal form when the database is already in the second normal form. Okay, and third normal form does not contain the transitive dependencies. So can you see over here, if this is the field A, that record A, and this is the B, so they are explaining each other. B, if it is 10, it means code A. If A is, let's suppose, C, it means code 50. So they are having transitive dependency. We have to avoid it. So data field A does not determine data field B. They are not related to each other in third normal form. Okay, so we create the data into the database into third normal form so that transitive dependency could also be avoided. So what could be the possible explanation? Further transmit the data. So we will be having another table now that will have parking violation code files. So we have only 3 codes in this example. A means meter expired, so $10 fine. B means parking in non-parking zone, $20 fine. C means no parking sticker, so $50 fine. So we define again the code parking violations with their code and explanations in this table. Okay, now when the ticket will be issued, we only need to know its key code. No need to write the fines here because they are already in this table. If you want to generate the report will consider all these 3 tables and your required data will be extracted. So this is how we use normalization concept to make our data in more proper form and to avoid the data redundancy issue. You can further go for more normalization stages, but as far as this subject is concerned, from accounting information perspective, for accountants this much information is more than enough. I hope you understand all the topics which I tried to cover today. If anything confuses you, or if you want explanation of something, please write in the comments section. I'll be answering you soon. Take care everyone, have a great day.